In this video, we'll solve part 3 to part 10 of question 5 of exercise 8.4. We have skipped part 1 and part 2 as they are simple and straightforward. Part 3 will be solved using two different methods. First is the standard method wherein tan and cot will be expressed in terms of sin and cos. Most of the steps involved are self-explanatory. We will give explanation wherever required in order to keep the video short. Here we go. The The steps that follow now are simply addition and subtraction of fractions. We know that the division of a whole number or a fraction by a fraction can be expressed as mm, numerator multiplied by the reciprocal of the denominator. Both the terms in the expression are the division of fraction by fraction. So this is the numerator multiplied by the reciprocal of the denominator, that is sin theta over sin theta minus cos theta. Here again, this is numerator which is multiplied by the reciprocal of the denominator, that is cos theta over cos theta minus sin theta. We know that if we take minus common out of an expression, then the positive terms of the expression become negative and negative terms become positive. Here we are taking minus common from the denominator. So the term becomes sin theta minus cos theta. The next step is simple subtraction of fractions. The factors of a cube minus b cube are a minus b and a square plus b square plus ab. So the factors of sine cube theta minus cos cube theta will be sine theta minus cos theta and sine square theta plus cos square theta plus sine theta cos theta. The common factor in the numerator and denominator, that is sine theta minus cos theta, will get cancelled. We know that sine square theta plus cos square theta is equal to 1. Replacing sine square theta plus cos square theta by 1 in the expression, we get 1 plus sine theta cos theta in the numerator and sine theta cos theta in the denominator. Separating the two parts of the numerator, we get 1 over sine theta cos theta plus sine theta divided by sine theta cos theta divided by sine theta cos theta, which is equal to 1. We also know that reciprocal of cos theta is sec theta and that of sine theta is cosec theta. If we observe the problem, the left hand side of the problem comprises of tan and cot terms which are reciprocal, and the right side uh, comprises of sec and cosec theta. Tan and sec theta are related by an identity. Similarly, the cot and cosec theta are related by another identity. In this method, we'll express the cot theta in terms of tan theta. Most again, the steps are simply the addition and subtraction of the fractions. Look at the first term, which is again a division of a whole number by a fraction. So numerator will be multiplied by the reciprocal of the denominator, that is tan theta over tan theta minus 1. The two terms in the denominator involving tan theta and minus 1 are same. They differ only in their signs. So we'll take minus sign common from the denominator of the second term. So that will leave this term as tan theta minus 1. This is again the simply a subtraction of fraction. So we have tan cube theta in the numerator, tan cube theta minus 1 in the numerator, and tan theta multiplied by tan theta minus 1 in the denominator. 1 cube is equal to 1. So the factors of tan cube theta minus 1 will be tan theta minus 1 and tan square theta plus 1 plus tan theta into 1, that is tan theta itself. The common factor in the numerator and denominator, that is tan theta minus 1, will be cancelled. We know that 1 plus tan square theta is equal to sec square theta. Replacing tan square theta plus 1 by sec square theta, we get sec square theta plus tan theta in the numerator and tan theta in the denominator. Separating the expression in two parts, we have sec square theta over tan theta plus tan theta over tan theta. This term is again the division of a fraction by a fraction. So numerator multiplied by the reciprocal of the denominator. Cos theta in the numerator will cancel one power in the of cos in the denominator. So we are left with cos 1 over cos theta sin theta plus 1. We know that the reciprocal of cos theta is sec theta and that of sin theta is cosec theta. We move on to the next part now. Here we have to prove that 1 plus sec a divided by sec a is equal to sin square a divided by 1 minus cos a. We can write left hand side as 1 by sec a plus sec a by sec a. The reciprocal of sec a is cos a and the division of sec a by sec a is 1. So we get cos a plus 1. Notice that 1 minus cos a appears in the denominator of the right hand side. We have to multiply both numerator as well as the denominator by 1 minus cos a. Cos A plus 1 can be written as 1 plus cos A, and that is multiplied by 1 minus cos A and divided by 1 minus cos A. We know that the product of sum and the difference of two numbers is equal to the difference of their squares. Applying the same, we will get 1 minus cos square A divided by 1 minus cos A. 1 minus cos square A is equal to sin square A. Part 5 is similar to the example 15 of the chapter. The solution of the example 15 is available on YouTube. The link of the same is given in the description. In order to solve this problem, we have to simplify the right hand side a bit to get the clue how to proceed. On simplification, we get 1 plus cos A divided by sin A. Notice the presence of 1 plus cos A as a numerator of the right hand side. Rearranging the numerator and denominator terms, we get 1 plus cos A minus sin A, and we rearrange denominator as sin A minus 1 plus cos A. Taking minus as common leaves the positive terms as negative and negative terms as positive. Since 1 plus cos A appears on the numerator of the right hand side, we will multiply both numerator as well as the denominator of left hand side by 1 plus cos A. Since 1 plus cos A appears in the numerator of the right hand side, we will not disturb the numerator part of the left hand side. We will simply modify the denominator part of the left hand side. This is, we'll multiply sin A with 1 plus cos A and 1 minus cos A with 1 plus cos A. That is the product of sum and the difference of two numbers is equal to the difference of their squares. That is minus 1 square minus cos square. One minus cos square A is equal to sin square A. We will replace now 1 minus cos square A by sin square A. Taking out the sin A from the denominator. So cancelling out the common factor, we get 1 plus cos A divided by sin A. It can be written in two parts, that is 1 over sin A plus cos A over sin A. Reciprocal of sin A is cosec A, and cos A divided by sin A is equal to cot A. Moving on to the next part. Simplify the right hand side a bit by replacing sec A by 1 over cos A and tan A by sin A over cos A. Upon simplification, we get 1 plus sin A divided by cos A. Note the numerator of the left hand side is the square root of the numerator of the right hand side. So in order to make the two numerators same, we have to multiply both numerators and denominators of left hand side by square root of 1 plus sin A. The product of 1 plus sin A and 1 plus sin A is 1 plus sin A whole squared, and the product of sum and the difference of two numbers is equal to the difference of their squares. So some product of 1 minus sin A and 1 plus sin A will be equal to 1 minus sin square A. We know that sin square A plus cos square A is equal to 1. So cos square A will be equal to 1 minus sin square A. Replacing 1 minus sin square A in the denominator by cos square A, square root of the square will result in the terms itself, that is 1 plus sin divided by cos A. Splitting the expression in two terms, we get 1 plus cos A plus 1 over cos A plus sin A over cos A. We know that uh, 1 over cos A is equal to sec A, and sin A by cos A is equal to tan A. Here in the numerator, sin theta is common, and cos theta is common in the denominator. Note that sin theta in the numerator and cos theta in the denominator makes tan theta, so we will not disturb these terms. We will somehow try to cancel these two terms so that we get tan theta. So we can write 2 sin theta square as is equal to as sin square minus sin square A. Sin square theta minus sin square theta. Similarly, we can write 2 cos square theta as cos square theta plus cos square theta minus 1. Replacing 1 minus sin square theta by cos square theta in the numerator. Rearranging the terms in the denominator. Taking minus common from an expression leaves positive terms as negative and the negative terms as positive. We will replace this 1 minus cos square theta in the denominator by sin square theta. So we have cos theta, cos square theta minus sin square theta. Cancelling out the common factors in the numerator and denominator, we get sin theta over cos theta equal to tan theta. We move to the next part. This problem is relatively simple and straightforward. We know that the square of a plus b is equal to a square plus b square plus 2ab. Expanding the first term, we get sin square a plus cosec square a plus twice sin a cosec a. Similarly, the expansion of next term gives cos square a plus sec square a plus 2 cos a sec a. Note that the right hand side of the problem has tan square term and the cot square term. We also know that 1 plus tan square a is equal to sec square a, and 1 plus cot square a is equal to cosec square a. We also know that sine and cosec are reciprocal. Similarly, the sec and cos are reciprocal. Rearranging the cos square term, we have sine square a plus cos square a, replacing cosec square by 1 plus cot square a. Sine and cosec a are reciprocal and they will finally cancel each other. sec square A is replaced by 1 plus tan square A. Cos and sec A being reciprocal, they will finally cancel each other. So we know that sin square A plus cos square is equal to 1, then cot square A, then 2, then 1, then tan square A, then 2 again. Summing all the numbers of the expression, we get 7 plus tan square A plus cot square A. Here we will express cosec A as 1 over sin A. So 1 over sin A minus sin A, and we will express sec A as 1 over cos A and minus cos A. Next step is simply a subtraction of fraction. Simplifying this, we get 1 minus sin square A in numerator and 1 minus cos square A in the numerator. Since sin square A plus cos square A is equal to 1, we can replace 1 minus sin square A by cos square A and 1 minus cos square A by sin square A. Common terms of numerator and denominator will cancel each other. So we are left with cos A and sin A divided by 1. Note that the right hand side denominator has two terms joined with plus sign. So in order to have similar construction, we will replace one of the denominator by sin square A plus cos square A. Also note that the numerator of the right hand side is 1. So in order to have numerator as 1 on the left hand side, we need to divide both numerator as well as the denominator of left hand side by sin A cos A. This will leave numerator as 1 and denominator can be expressed as sin square A divided by sin A cos A plus cos square A divided by sin A cos A. Upon simplification, we get once we simplify it, we get 1 over sin A divided by cos A plus cos A divided by sin A. That is 1 over tan A plus cot A. We move on to the next problem. In this problem, we have three parts instead of usual two parts. We will prove first part equal to third part and then second part equal to third part. Let us start with first part being equal to third part. So 1 plus tan square A divided by 1 plus cot square A. 1 plus tan square A is equal to sec square A and 1 plus cot square A is equal to cosec square A. We know that cosec and sec are cos and sec are reciprocal. Similarly, sin and cosec are reciprocal. This is now a division of fraction by fraction. The division of a fraction by fraction can be expressed as the numerator multiplied by the reciprocal of the denominator. So here is the numerator which is multiplied by reciprocal of the denominator. That leaves sin square A by cos square A which is equal to tan square A. So we have proved that first part is equal to third part. We will now prove that second part is equal to third part. 1 minus tan square A, 1 minus tan A divided by 1 minus cot A whole square. We will substitute 1 over tan A in place of cot A and the denominator is the subtraction of fractions. So we'll simplify the denominator. Again, this is a division of a whole number by a fraction. So it will be numerator multiplied by the reciprocal of the denominator, that is tan a over tan a minus 1. Rewriting the terms, tan a 1 minus tan a divided by tan a minus 1. Note that we have taken minus common in the denominator. So we know that when minus is taken common from an expression, the positive terms of the expression become negative and negative terms become positive. So we have the square of minus tan a 1 minus tan a divided by 1 minus tan a. Common factors will cancel each other. So we are left with a square of minus tan a, which is basically same as tan a multiplied by minus tan a multiplied by minus tan a. That is positive of tan square a. So we have proved the second part equal to third part. So in fact, we have proved the first part equal to second part equal to third part. If you have liked this video, please subscribe to it and share it.